How to draw an activity on arrow network diagram part 2. In this video, we'll be looking into the application of dummy activities in an AOA network diagram. Before we move on, first of all, we will understand what is a dummy activity. A dummy or a dummy activity is a type of operation in a network which neither consumes any time or any resource. It is merely used as an identification for dependency among the operation. A dummy is usually represented by a dashed arrow, something like this, and we usually do not label dummy activity. Now we will understand the uses of dummy activity in an AOA network diagrams. The first use or the purpose of dummy is the grammatical purpose. What exactly is this grammatical purpose? So according to this, no two activities should have common initial and final node. So this is very important in drawing the network diagrams. We have also looked in our previous video regarding the procedure to draw the network diagram or the rules in order to draw a network diagram. So in that we have one rule which states that two or more activities cannot have common initial and final node. So we will look into this situation by taking an example. So we have an activity and predecessor relationship. So we totally have three activities for this example of grammatical purpose. So activity P, Q and R. So if we can see here, activity P and activity Q do not have any predecessor, whereas activity R has predecessor activities as P and Q. So now let us try to draw the network diagram for the given activity and predecessor relation. So as mentioned in the previous video, an activity on arrow network always starts with one single initial event, or we can call it as a node, which is represented by a circle. So I have labeled it as the first node or the first event. Now we can see we have two activities, activity P and activity Q, which has been put up in the table, do not have any predecessor. So that means these two activities, that is P and Q, are our initial activities. So I'll be drawing activity P and Q over here. So we have activity P and we have activity Q. So now you might wonder why I have drawn these two in this fashion. So this is because we can see our third activity, which is activity R, is having a predecessor as P and Q. So in order to draw activity R, both activities P and Q should be completed. So now you can see at event number 2, I have activity P and activity Q. Both are completed at event number 2. So from this, we can have activity R and have this closing final node, which would be numbered as event number 3. So now, is this network diagram correct? Now if we look at the first two activities P and Q, so here we can clearly see that P and Q are having common initial event. So this is not at all a problem, since we know that we can have multiple number of activities starting from a common or starting from an initial event. And also in the subsequent events we can have multiple activities emerging out or bursting out. But the problem arises at event number 2. So what is happening at event number 2 is both these activities P and Q, which is having a common initial event, do also have a common final event. Now we can see here we have activity P starting from event 1 and ending at event 2. Similarly, we have activity Q which is starting from event 1 and ending at event number 2. So as per the grammatical purpose, we can see here no two activities should have common initial and final node. So here we have activity P and Q which is having common initial and final node. So this type of drawing a network diagram is not permissible. So in order to avoid this type of grammatical error, we are going to use a dummy activity which neither consumes any time or resource. It is only going to consume the time and resource of the previous activity through which a dummy is been drawn. So now we will see how a dummy is going to help us to avoid this grammatical error in an AOA network diagram. So similarly, we'll start with the first event or the initial event, which I'll be numbering it as 1. So now we'll have two activities P and Q, which are our initial activities. So I'll have an activity P and I'll have activity Q, right? So now, in order to draw an activity R, we have a predecessor relation, that is P and Q. So what does it mean? Both these activities P and Q should be completed in order to start activity R. Now how do I use a dummy over here? So here we can see at event number 3 we only have activity Q as its predecessor, and at event number 2 we only have activity P that has been completed. So in order to have our activity R to start with, we need to have some sort of relation. Okay, so wherein we have both activities P and Q at that particular node, and also we cannot have these two activities joining these two events, since it is going to avoid or it is going to like have the grammatical error. So what we can do is we will be using a dummy activity which do not consume any time or resource, but it is merely used as a dependency in our network diagram. So what I'll do is I'm just going to introduce a dummy activity from activity P to Q, or event number 2 to event number 3. So now what is happening here is we have activity Q which is directly coming over to event number 3, and we have activity P which has been diverted. So you can see a dummy activity is just like a diversion, right? It is just like a freeway wherein you need not, just like if you take an analogy, it is just like a traffic light or a traffic signal, wherein what happens is it is just like a freeway, free left turn you can say in this example. So you are just diverting the traffic in a freeway so that you need not stand here for some time. So this is just an analogy. So what is happening is whatever the resource and the duration that the P is consuming, it has just been diverted to this node, right? So what is happening is at event number 3 we have activity P coming over, and we have activity P also coming over to event number 3. So now we can have our last activity R, so which is having a predecessor relation as Q as well as activity P. So you need not worry about the labeling of this. As mentioned, the dotted arrow indicates it is a dummy activity. So this would be the right way of representing a network diagram using a dummy. So now let's look into the second purpose of using a. The second use is for the logical purpose. So what exactly is this logical purpose? Any activity cannot have dual identity in a network diagram, or in other words, it should have a unique identity. So what exactly does this statement indicate? So in a network diagram, we cannot have two activities with same name. That means we cannot have two activities with labeled as A or B, C, etc. So we cannot have two activities with same name. So each activity should have a unique name, or it should be a completely different activity, right? So now we will look into this with an example. So we have an initial event, we have two activities which are denoted as P, and then we have activity Q and R. So in this example, we can see activity Q is having a predecessor as activity P, and again activity R is also having a predecessor activity as P, right? So this is not the correct representation because we have two activities with common name. So this type of representation is not allowed in a network diagram, right? So in order to avoid this, you might wonder why we can't have just one single activity P, and then through that we can split it as Q and R. Yes, we do have that option, but this is a general example what I've taken here in order to tell you that we cannot have two activities with a common name. We'll have a detailed example wherein you will understand much clearer on what is the exact logic behind this logical purpose or the use of this dummy. So in order to avoid this, what we can do is we can introduce the dummy activities so that the logic is not changed, right? So this is not the correct representation of the network diagram. Instead, what we can have is we can have single activity P, and then I'll be introducing two dummy activity, right? So what is happening? It is not that it is sharing the resource. One needs to keep in mind that if I have two dummies through one single activity, it doesn't mean that 50% of the resource is going towards event number 3 and 50% of the resource is going towards event number 4. It is not so. Whatever is the time and the resource that has been consumed by activity P. For example, if the duration of activity P is 2 days and it is consuming 2 resources, then the same value of 2 days and 2 resources will be moved towards event number 3, and the same quantity of 2 days and 2 resources will be moved towards event number 4, right? So this is very important to keep in mind that whenever there is a split of an activity using the dummy, it doesn't mean that the resources and the duration will be split. Whatever is the resource consumed or the duration consumed by the predecessor activity before that of the use of dummy, the same value will be moved to through these dummies. So now what we can have is we have activity P that has been running at event number 2, sorry, event number 3, and event P again at event number 4. So now I'll be having activity Q and activity R, and finally the final event, and this would be the correct representation of an activity on arrow network diagram using the logical purpose of dummy, right? So these are the two reasons why do we use a dummy activity. The first purpose was for the grammatical purpose, right? The second one is for the logical purpose. So now we'll take up a couple of examples in order to understand the real-time application of using a dummy activity in a network diagram. So we'll take up the first example. So we are supposed to draw an activity on arrow network diagram, AOA network diagram, for the given activity and predecessor relationship. So we totally have 6 activities A to F, and then we have the predecessor relation. Now we'll try to draw the network diagram and see what are the challenges that we are going to face in order to draw this network diagram, right? So we'll start with the first activity, and that activity is activity A, and it does not have any predecessor, and we can see all the other activities do have some predecessor activity. So that means that we only have single initial activity, right? So now before we start with drawing the network diagram, as mentioned in the previous video, we have to start with an initial event or an initial node. So from this we'll be drawing the first activity, which is activity A. So once the activity A is drawn, we are going to close this activity using an event, right? So next we'll go with the next activity, which would be activity B and activity C. Why we are considering both these activities is because both activity B and C have a common predecessor, that is activity A. So what does this mean? So in order to start activity B and activity C, activity A has to be completed. So if we look at our network diagram here, activity A is completed. So that is represented by this node or an event. So now we have this B and C activity, which are parallel in nature. So we have activity B starting over here, and in order to complete this activity we are going to have this event, and then we have activity C. In order to show that the activity is completed, I'm going to end with an event or a node, right? We'll move on to the next activity, which would be activity D. And in order to start activity D, activity B should be completed. So that is the predecessor, which is activity B. So this is not at all a difficult task. After the completion of activity B, which is at this event or the node, we will be having our activity D. So once the activity D is been drawn, we are going to close it using a node. All right. So next we'll go the next activity, which would be activity E. Now, to draw activity E, we have the predecessor, which is B and C. So in order to start activity E, B and C should be completed. So now if we look at our network diagram, so activity B is completed at this node, right? And activity C is completed at this node. So in order to draw activity E, we need to have some relation at a certain node wherein both C as well as B should be meeting each other. Only when the two activities meet at a node, that indicates the predecessor relation for that activity, which would be coming in the successive after the event. So for example, if I have this activity E over here, if I draw an activity E something like this, so what is going to happen? If you look at the network diagram, so activity E is having a predecessor as only activity C, because at this event where activity E is starting, we only have activity C that is coming onto this event or the node. Whereas in order to start activity E, B and C both should be completed. So there has to be some relation, there has to be some way, right, wherein we have some relation with activity B, right? Now how do we go about with it? So this won't be the correct representation of this network diagram, right? One is from B to C, other one is from C to B, right? So now we'll take up one by one both this condition one by one. So first we'll take the first condition wherein we have an dummy activity which is coming from top to bottom in this diagram. So now what is happening? We'll consider the first event. So the topmost event. So at this event, what is happening? We have only activity B that is coming onto this node. So be careful. I'll just repeat it again. At this node which is highlighted, we only have one incoming activity, which is activity B, right? So what does this indicate? So the dependency at this node is only activity B, right? It is only activity B which is coming onto this node. Whereas the node at the bottom, which are all the activities that are coming onto this node? One is activity B through the dummy, it is going to come over here, right? So activity B is there at this node, and the same activity I am just transferring it over to this node. And also we have activity C which is coming onto it directly. So there are two activities which are coming onto this node, that is activity B and activity C, right? In general, if I want to say, so at this node at the top we only have activity B, and node at this bottom we have activity B and activity C. Okay, so be careful. Even you can look at the table that has been mentioned over here and just compare it with what are all the predecessor relation for these two activities, right? So now we'll take up the second, wherein we have the dummy activity which is flowing from activity number C to activity B. So what is happening over here? If we consider this node at the bottom, we have only one incoming activity which is activity C. So that is the node dependency is only activity C. Okay, at this node at the top we have activity B that is directly coming over, and I am drawing this activity C through a dummy activity over to this node. So the node dependency over here would be activity B and C, whereas at this it is only activity C, right? So now which one is the correct option? So if you look at the table, for activity D, we only have B as the predecessor, right? In order to draw activity B, only B should be the predecessor. Whereas to draw activity E, both B and C should be the predecessor. So in order to get, we are going to have our dummy through B to C. So what is happening? At this node, we have only activity B, and at this node we have activity B through the dummy as well as activity C. So this would be the correct way of drawing the AOA network diagram using the grammatical purpose, right? But this is not done yet, since we do also have one more activity which is activity F. So in order to draw the activity F, we have D and E as the predecessor, right? So activity D and activity E has to be completed in order to start activity F. So now how do we go about with this? Since I have explained you about the dummy activity, it is quite common that students generally go with this option, that is connecting activity E and activity D through a dummy. Or you can also draw it in the opposite direction. Since it is the last activity which we would be drawing, it doesn't make much of a difference, right? So now, is this representation correct? So if you look at this, it is correct to some extent, but this is not the exact, I mean the correct way of representing. So there is a dilemma that it is also correct and it is also not correct. So why is it correct? Because if I draw the activity F, it doesn't change any relationship or the predecessor relationship to activity F, because activity D is over here and I am drawing this activity E through the dummy. So we'll have the node dependency as D and E in order to draw activity F. So that is what we have here in this table. But one thing we have to keep it in our mind is that we should avoid unnecessary dummies in a network diagram. Even though you have an option to draw dummy, doesn't mean that you can have n number of dummy activities in your network. So we have to use a dummy activity only when it is necessary. It is not that since the dummy activity does not consume any time or any resource, it doesn't mean that you can have n number of dummies, right? So why is it not advisable to use unnecessary dummy? Is that since it is a very small network diagram, it doesn't matter. But If we have hundreds of activities, sometimes 200, 300, 400 activities in large projects, in order to draw the network diagram, if we use unnecessary dummy, it will create a lot of confusions. And in order to determine the critical path, determine the total duration of the project, etc., it becomes very difficult to trace or to track the activities if we have unnecessary dummies in our network. So for that reason, we have to see to it that we will avoid the dummy activities as much as possible and use it only when it is required or only when it is necessary. So this unnecessary dummy should not be used. So what would be the other option? Since D and E are almost the last activities and they do not have any other relationship in our network diagram which is mentioned in the table, right? So what we can do is we will just merge these two activities D and E. Then we will be having the activity F and then I'll be closing. So this would be the correct representation of an AOA network diagram. So we can just look at it. Activity A, you can just compare it with the table. Activity A is the first activity. B and C are the parallel activities which is starting after activity A is completed. So activity D is going to start after activity B is completed, and activity E is going to start after both B and C are completed. So for to draw the activity E, I have activity C that is coming over, and I have taken the help of a dummy in order to show the dependency of activity B to activity E. And then we have the very last activity, which is activity F. In order to draw this activity F, we have activity D and E as our predecessor. So network diagram. But this is not done yet because we have not yet numbered our events. So numbering the events using the Fulkerson rule. So according to this, we'll start with the first event. So if you want, you can look at the previous video of numbering the events. So here I'll be using the method of tracing, which would be very helpful in order to draw or in order to number the events correctly without any mistake. So we'll start with the first event. So this I'll be numbering it as 1. So once it is done, so I'll be highlighting this. Now what I'll be doing is I'll be tracing all the activities which would be starting from event number 1. So fortunately we only have event number 1. So I'll be tracing this. So once it has been traced, I'll move on to the next event. Okay. So now I'll be numbering it as event number 2. So now I'll be moving on to event number 2. So from here, I'll be tracing all the activities which are emerging from event number 2. So we have two activities. So I'll be tracing these two activities. So now we'll look at the events where all the activities coming onto it are traced. So now if we look at this event at the top, we have only one activity or incoming activity onto this event. Now if you look at the event at the bottom, we have one activity which has been traced and there is one more activity which is not yet traced, right? So since it has not been traced, we cannot number this event. So don't worry whether it is a dummy or it is not a dummy. All the activities or the incoming activities has to be traced, right? So therefore I can only number the event which is at the top. So this I'll be numbering it as the next event number. So after 2 it would be event number 3. So now what I'll be doing to event number 3 now. So now from event number 3 I have two activities which are starting. So I'll be tracing these two activities. So now I have two events that has been ending. So if I look at this event, right, so we have one activity which has not been traced, so I cannot number it as of now, whereas the event over here, both these incoming activities have been traced, so I'll be numbering it as event number 4. So now I'll move on to event 4. So from this I have only one outgoing activity, which is activity E. I'll be tracing it. Now if I look at this event, both the incoming activities have been traced. So this I'll be numbering it as event number 5, and from here I have only one activity which is emerging, and this I'll be numbering it as event. So this would be the final AOA network diagram. Right. So now we will look into one more example of using a dummy activity. So we have again 6 activities, and these are the predecessor relation one by one. So if we look at the first 3 activities A, B and C, all these 3 activities do not have any predecessor. That means all these 3 activities are the initial activity, and you should keep in mind that you can have n number of activities as initial activities. There is no problem at all. You can have 1, 2, 3, 4, 5, etc. Any number of activities. You can start it from an initial event. Right. So in order to draw the network diagram, AOA network diagram, or the activity on arrow network diagram, we'll start with event, the initial event. So from this we will have these 3 activities A, B and C. So we have activity A. After drawing the activity A, I'll have the end event or the finished event. Next I have activity B. I'll be closing it with an event, and I have activity C, which I'll be closing it with an event. So now you might wonder why I have drawn something like this: A, C and then B. Why not A, B, C, etc.? So this we'll see once we get on to the further activities, right? So now we'll move on to the next one, which is activity D. So in order to draw activity D, I need to have a predecessor relation as A and C, right? In order to draw activity D, A and C should be completed. So now in order to draw activity D, A and C should be completed. I cannot directly join A and C because it is going to violate the first purpose, that is the grammatical purpose, right? That is, no 2 activities should have common initial and common final nodes or common final events. So that is going to violate. So in order to avoid that, what do? We usually draw a dummy activity. So what do we do here? We'll draw a dummy activity which is coming from activity C to activity A, right? So now at this node, right, at this node we have 2 dependencies. One is activity A, the other one is activity C. So I can easily draw an activity D through this. So once activity D is drawn, I'll just close it with an event, right? Hope you have got this. In order to draw activity D, I should have activity A and activity C as the predecessor. Since I cannot directly join activity C to this node because it is going to violate the grammatical purpose. So you can just look into the previous example, so where I have explained regarding this, right? So in order to avoid that, I'll be drawing a dummy, or I'll be adding a dummy activity to this node. So I have activity C that is coming over here and activity A in order to draw this activity D. Now let's get on to next activity, which is activity E. So in order to draw activity E, B and C should be completed. So in order to draw activity E, activity B should be completed, and again I have activity C. So I cannot directly join activity C, as again it is going to violate the grammatical purpose. Therefore I'll be introducing a dummy over here. Now you can see I have 2 dummies, right? I have 2 dummies through activity C. Now what is happening at this node at the bottom, right? I have activity B and I have activity C that is coming over. So now I can draw activity E, right? So I have activity E. Last activity is activity F and the predecessor relation is activity D and activity E. So activity D and activity E completing will have activity F, and in order to show the completion of activity F we'll have the final event. So this would be the final network diagram, AOA network diagram, and this is the application of the logical purpose of using a dummy, wherein we'll have two dummies through a common activity, right? So now we'll events using the Fulkerson rule. I hope you are now familiar with the numbering the events using the Fulkerson rule or using the tracing method. So we'll have event number 1 over here. Next we'll have to trace these three activities. Now we have to check in all these three events which is that event all the incoming activities have been numbered. So it is only the activity C which has been numbered, because if you look at the top event there's one dummy which is not been traced, and again the second dummy is not been traced, so I cannot number this. Therefore I'll be numbering this as event number 2. So once I've come to event number 2 I'll be tracing the other two dummy activities. Now I have both these events which can be numbered, right? Because all the incoming activities to both these events have been completed, tracing is completed. So I can have event number 3 on top and 4 at the bottom, or 3 at the bottom and 4 at the top, since these two are parallel events, right? Therefore you can number in any fashion. That does not affect anything in the network diagram. You can have either 4 at the bottom or 3 at the bottom and 4 at the top, right? So now once tracing of event 2 is done, we'll go on to event number 3 and we'll trace the activity which is emerging out. Now if you look at this event, there is one more activity which is yet to be traced. So what we'll be doing is we'll move on to event number 4. Through event number 4 I'll be tracing this activity. Now if you look at this event, both the activities have been traced. This I'll be numbering it as event number 5. So from event 5 we have one last activity. So once it has been traced, so this would be numbered. So this would be the final AOA network diagram, and also it has an application for the logical purpose of using a dummy activity. Hope the video was helpful.